Alright guys, obviously Monday we have our first quiz of this unit, assuming nothing happens over the weekend, and we all see each other on Monday. So, here we go, your 3 stars. Alright, this first one, we have a to the m times a to the n. Basically what it's saying is if you have 2 variables and you're multiplying them and you have exponents, what you're going to do is you're going to add the exponents. Okay. Next one down, I have a variable times a variable, so a times b, and I'm raising it to an exponent. When it's on the outside of parentheses, what happens is the exponent is brought in to everybody inside the parentheses. Okay. If I have a variable to a negative exponent, so a to the negative m, how I handle that is I go ahead and I put a 1 over it. And then you move the position of the variable and the exponent, and it switches the exponent to positive. Okay? If I'm dividing 2 variables that are the same by each other with different exponents, what I'm going to do is I'm going to subtract the exponents. Okay? If I'm dividing 2 variables and it's raised to the m, I can do just like I did on the multiplication. I can go ahead and bring that m into both. Alright. On the bottom here, I have the nth root of a, so the nth root of variable can be rewritten as the variable to the 1 over n. Okay. Over there, I've got a variable to an exponent. So what you're going to do is you're going to go ahead and multiply your exponents. Anything to the 0 power is 1. Okay, and lastly, we got down here another, it's kind of like the one next to it. Okay, you have your radicand, your exponent, and your index. Okay, so that's how that one is set up. All right, so complete the rules here. All right, so I have the nth root of a times the nth root of b. Remember, all that means is you have to have the same roots when you're going to multiply here. So I can rewrite this as the nth root of a times b. Okay, same thing with division. Remember, you just need the same kind of root to divide it. All right, and that's the first part of the 3 stars. The second part of the 3 stars, we have our what criteria is considered to be like radicals. It's the same index and same radicand. Okay, those are the only 2 answers I will accept in any order, but those are the only 2 answers I will accept on that. Okay, number 3. All right, all it is simplify, so you just kind of follow your rules. Here we go. So the key to this, though, is I see this here, use only positive exponents. So that means anytime a negative exponent shows up, I'm going to have to deal with it. I'm going to have to make it positive. So this first one, I've got negative 12 x squared times 3x to the 6th. So I do number times number, variable times variable. So negative 12 times 3 is negative 36. Okay, and x squared times x to the 6th. Remember, that's a property on the top. All we have to do is add our exponents. So that will give me x to the 8th. Okay, now when I'm looking at this, I see negative 36. Negative 36 is not an exponent, so we don't have anything to move. Okay, and you don't move coefficients to begin with. That's a coefficient, we don't touch it. All right, that middle one. All right, we're dividing here, so numbers divide normally. Unfortunately, you cannot divide 4 by 28. However, you can reduce them. 4 goes into both of those nicely. So 4 divided by 4 is 1. 28 divided by 4 is 7. Okay, then I go ahead and use my exponent rules from up top. Anytime we're dividing, what we're doing is we're really subtracting our exponent. Okay, so I have 6 minus a negative 2. Minus a negative is really plus a positive. So I'm going to end up with 8. When you're doing your operations, they automatically default to the numerator of a fraction. So that's where your answers are going to go. Okay, I have 3 minus 6 for the y's. All right, so that would be y to the negative 3. Okay, and then finally 4 minus 4, which is 0. So a couple things we have to do to simplify this. Number 1, anything to the 0 power is 1. So essentially that z can go away. All right. The other thing to this is we have hey guys, sorry about that interruption there. Okay, so we are, again, just looking at where we're at here. We can get rid of that z, okay, and it's the 0 power, so it's like saying it's times 1, we don't need it. Okay, so we do got to fix that y to the negative 3. So first off, the 1 doesn't change, the 7 doesn't change. Those are still very much in the same spot. Okay, x to the 8, not a problem. All right, that is a positive exponent. We're good. All right, to fix the negative 3, all we're going to do is shift where it's at. We're going to move it to the denominator, and it's going to become a positive 3. Now, I had a teacher a long time ago say, hey, what you do is you bring it downstairs. If you want to change its attitude, bring it downstairs. So that's what we're going to go with here. So there's that one there. You should have 1x to the 8th over 7y to the 3rd. All right. Number 5, a couple things here. Right away, I see z to the 0 at the end. Anything to the 0 power is 1, so I actually don't even need that. I can get rid of that. Okay. Now, you got to be careful because, remember, the 0 is only attached to what it's directly touching. So, for example, if that said 4z to the 0, I would still have to leave the 4 there because you know what? It would look like this. Okay, if you see this, okay, that doesn't make the whole thing 1. It only gets rid of the variable, and so you'd still be left with 4. So you got to be careful with that, all right? So make sure come test day that you don't fall for that, because that is a trick that we can throw at you, all right? Other than that, what we have is number times number, variable times variable. So 7 times negative 3 is negative 21, and then I don't have any like variables, so they just kind of come together here. All right. Now, the one problem I do have is, again, we want positive exponents. Okay, so positive exponents, I have a negative 1 there. I have a negative 5. So what I'm going to do is I'm going to rewrite this. Now, that negative 21, that stays, okay? It is a constant. We do not move constants. They stay where they are, okay? The only thing that we can shift are variables with their exponents. Okay, that is what we can shift. That is all we can do. So I have x to the 5th in the denominator now. That is what your answer looks like. Okay, so do not try to move constants. Okay, number 6. Okay, simplify the following. All right. So remember, with the square roots, cube roots, you gotta pay attention to which list we're using. Okay. In this case, I have the square root of 121. That is a perfect square. That is 11. So hopefully I haven't graded your quizzes yet from today, so hopefully we'll see what that looks like, and maybe we got that. All right, and then remember with square roots, we divide our exponents by 2. So 10 divided by 2 is 5, and 2 divided by 2 is 1. So there's that one for you. Number 7, we've got cubed roots. Okay, so now I'm looking at cube roots for 27. The cube root of negative 27 is negative 3. Okay, and then instead of dividing by 2, I divide by the index. The index in this case is 3. So 12 divided by 3 is 4. 9 divided by 3 is 3. So there we go. All right, nice and simple. 2 easy ones to start off. You don't have to worry about breaking it down. It's pretty easy. Then we get to these. Okay, this one here. All right. Now, what you're going to see is, remember, when we take the square root of a parenthesis, what ends up happening, I don't know why that's missing. What ends up happening is this just becomes this. Now remember, what does that actually mean? That means it's out twice, okay? And you should FOIL it, okay? If you FOIL that, you end up with x squared minus 12x plus 36. That's what you would get on that one. All right, so you might have to FOIL on this test, so be ready for that FOILing. Okay, number 9, square root of 45. Well, 45 is not a perfect square. So what we have to do is we have to figure out something that goes into 45. All right, what goes into 45 that is a perfect square is 9. 9 times 5 is 45. Okay, so the square root of 9 is 3. The square root of 5, I have no idea, so I leave it. Okay, and then there's square roots, right? So I'm dividing by 2. So if I divide 9 by 2, well, that doesn't work nicely, but I know that 2 goes into 9 4 times with a remainder of 1. Okay, 4 divided by 2, that's nice. It's just 2. Okay, and I have no idea what's supposed to be in that exponent because I got deleted. So let's see if I can figure it out really quick. Okay, there is no exponent there. So we're going to assume that it is 1. All right, so we're going to assume this exponent is 1. I cannot divide 1 by 2, so that actually just goes underneath. Okay? So what I have here is I have to combine outside with outside, inside with inside. So outside I have 3, I have x to the 4, and I have y squared. On the inside, I have my 5, and I have an x, and I have my z. So there you go. So there will be one of those. We have to do that. Okay. All right, we're on number 10. Okay, about halfway through. Sorry. So number 10. All right, we're gonna do some multiplication here, and then we gotta simplify. All right. So as I go through, remember number times number, variable times variable. Okay. So I've got 3 times 18. All right, which is 3 times blah. Okay. 3 times 18 is, I want to say, 54. That's right, 54. I don't know why that took me so long. 54. Okay. And then I go add my exponents. So 7, 6, and 5. Okay. Now I gotta break down that 54. What multiplies in 54? One of them has to be a perfect square. Okay, so if I'm looking at that, I'm thinking maybe 16, I think. That might be a good one. So let's try it. So 54 divided by 16. Nope, that doesn't work. So 54 divided by 4, that doesn't work. Oh, Jesus Christ, 9. Why am I an idiot? Okay, anyway, so 9 works on that, okay? So 9 and 6 work with that. So again, 39 is 3, 6, okay? Divide all your variables by 2. Goes in there 3 times with the remainder of 1, okay? No remainder. Once with the remainder of, twice with the remainder of 1. So again, outside with outside. And inside with inside. And then we have the 5 and 9, or 6. 8. Yeah, that was just a mess. I apologize. That was rough. Got distracted there for a second. So that's what it should look like. I apologize, guys. All right, number 11. We'll try again here. Number 11. Give myself some space. So I'm just going to straight divide. So right away I have 27 divided by 3, which is 9. Okay, and then 12 minus 6, which is 6. Okay, I'm still inside my square root. Square root of 9 is 3. 6 divided by 2 is also 3. So there's that one, nice and simple. Last one, we're doing cube roots there. So 54 divided by 2 is 27. Okay, and so the cube root going here. And then 21 minus 3 is 18. Okay, instead of divided by 2, I'm divided by 3. But first, the cube root of 27 is 3. Okay, and if you divide 18 by 3, you end up with 6. So there's that section. I apologize for how rough I started off, but there's that section here. Number 13 is will be the last problem on this part of the review. So first thing, width and length of a rectangle. It says what is the area. So all you're doing is multiplying the length times the width. Okay, so length times width there, 4 times 32, which is, let's see, that's 8 carried the 12, so 128. Okay, you gotta see if you can break that down at all. 64 times 2, I believe, is 128. Hopefully I didn't mess that up, because if I did, I'm gonna be upset. So finally, take cube root of 64, which is 4, and the cube root 2 stays. You can't take that. So there you go. There's that. That's part 1. Part 2 will be done shortly, and then I will also get the answer key up there for you. Again, I apologize for the rough middle part there, but you'll get through it.